abstract class and what are the different points, important points related to abstract class and abstract method that we have seen in the last session. So why the abstract classes are known as partial abstraction is because they contain concrete methods as well as it contains abstract methods. Okay, that is why it is partial abstraction. We have seen one example of student marks, which is an abstract class. Right? So we are going to see one more example of abstract class and then we will go forward with the next points. I'm creating one class. Sample. So here we will create one abstract class named animal. Okay. Before going forward, I will show you one more example here for the abstract class. So example of abstract classes, suppose we have to calculate area and all. So we can create the shape class as abstract class and you can create particular shapes, that is circle and rectangle as concrete classes, which is extending this shape class. Your inheritance is there, right? So in this shape class, you can create abstract area method because there is no need of creating any area implementation here in this shape class because each and every shape will have its own formula for calculating area. So there is no point declaring or defining this area method here into the shape class. So this is, you can create this area method that's abstract in the shape class, which is a parent class, right? And you can extend that or you can override this area method into the circle and rectangle classes and calculate the area that according to the created classes. Okay? Because the main, basically the calculation formulas are different for calculating area of circle and area of rectangle. Similarly, the other shapes as well, right? So this coming back to your this animal example. Here we will create one abstract class animal. In this animal class, I am creating one abstract method itself, only single abstract method. Abstract void display method. Okay, you can create any other as well. Saving this abstract class. Now I will create two classes which are extending this animal class. Suppose that class is class tiger. Extends animal. Okay. So as this is a concrete class, you have to provide the implementation for this display method. Okay. So here I'm adding unimplemented method. We will add some statement here. System without println. Tiger class display method. Saving this. Now, suppose we have seen anonymous class, right? So we can use anonymous class to provide the implementation to this abstract method as well. Okay. So instead of creating a separate class here, you can provide the implementation without saving it, without creating any separate class, and you can directly give the implementation to this also. How to do that? So first I will create the object of tiger class. New tiger. t dot display. I'm calling t dot display. This is normal creation of object and calling the method. Then you can use abstract class as reference to create the object as well, like animal a is equals to new tiger. We have seen this upcasting concept, a dot display method, right? So you can call the method in this way as well. This also we have seen in the last example also. Okay. Now here I'm creating animal another reference a1 is equals to. Now I'm directly trying to create or initialize this animal reference itself using the animal. But you know that this is an abstract class, we cannot instantiate it. We cannot create the object of it, right? So instead of this, we can use anonymous inner class here to provide the implementation to this abstract method inside this constructor call. Okay. So here we are basically using new animal anonymous inner class to provide the implementation to this abstract void display method. Okay, so this is the class. This is constructor call, and after that we are giving brackets for the class implementation to provide the void display methods implementation. Okay, and at the end we are giving semicolon. You can simply write some statement here, system.out.println anonymous inner class created to provide implementation to display method. Okay. So this display method is abstract method. Implementation to provide abstract display method, I will write you. Okay. I'm saving this. Now, how to call this? This is anonymous inner class we have created, right? So to call this display method, we will use the same reference. This is a reference variable. Okay. Now this is a reference variable. It is not on object. This is object, but this is reference variable where we are using this reference and giving some implementation to the void display method, which is abstract method, using this animal reference itself. Okay. So if you want to call this display method, we will use the same reference name, that is a1.display. Saving this, I'll execute and let's see the output. Okay. So you can see for first tiger classes object we have created. So it is calling directly the tiger's display method. Then we have created we have used upcasting concept to create the object of tiger and save it into parent animal class reference. And the last one is we have created the animal reference and providing directly anonymous class implementation for providing implementation to this abstract method. Okay. So this is the way where you can use these anonymous inner classes along to provide the implementation to the abstract methods as well. So यहाँ पे आप abstract class में abstract, non-abstract, both methods you can write. If you are mentioning any one method as, if you are writing any one method as abstract method, then you have to make that class as abstract class. Abstract class can be empty. Okay, there is no, if you don't want to provide any or write any method inside it, you can keep it blank, anything, no variables, no methods, that is also fine. So we are using this single abstract method we have written into this animal class. So this is an abstract class itself. As this abstract class is known as partial abstraction because we can write concrete and abstract methods inside it. You can create a separate class to provide the implementation, or you can use the anonymous inner class also to provide the implementation to the abstract methods. Here I have created a single method, which is an abstract method, but you can use, or if you have multiple methods, multiple abstract methods, you can write n number of abstract methods in a class. So if you have that, you can also use the same anonymous inner classes to create or provide the implementation to all those methods as well instead of creating a separate class. Clear? Okay. Any doubt? So you can, so this is a simple example, shape and circle rectangle. You can use your own logic to complete this. Okay. Next topic is interfaces. So basic interfaces is what? What is interfaces? Interfaces is nothing but a service requirement. You can say it is SRS, service requirement specification, where one client came to you and asking, I want college automation system. I want to design college automation system. What you will do, you will first ask that person, whoever is client, you will ask what things you want to add into your college automation system. What are the things? What are the functionalities? So first functionalities, as it is a college, you need to take some admission, right? Then I want some merit list. I want some exams related functionality. I want administration work related functionality and attendance related functionality. So the client is giving you all these list of functionalities that he wants or she wants in his application. Okay, that system, that is a college automation system, or any, you can consider any automation system. You will become the service provider for these, all these functionalities, right? So it is nothing but interfaces is nothing but it is another method of abstraction, implementing abstraction in Java. We can achieve the abstraction using abstract classes and using interfaces. An interface is a blueprint of a class. Okay, why it is a blueprint of class, that we will see. Interface in Java is a mechanism to achieve fully abstraction. Okay, fully abstraction. Why it is called a fully abstraction, that also we will see. There is no exact definition for interfaces. Based on usage, there are several multiple definitions for the interfaces. No single definition. There are multiple definitions based on the usage of the interfaces. The first is nothing but SRS, which I have explained. SRS, Service Requirement Specification. It is by default considered as interface. Why? We as a service provider only listing these functionalities which we want to develop into our college automation system, which the client wants in this particular system, right? So we are noting down. So this is we as a service provider providing all these services to the client. That is why it is nothing but the service requirement specification. Service requirement, system requirement specification, service requirement specification. Any contract between client and service provider is also considered as an interface. Okay. Any contract between client and service provider is considered as an interface, because client is giving you some requirements and you are going to develop all these functionalities. That is why you are a service provider. You are providing all these services to the client. That's why this is a contract between a client and service provider. Okay. Now, what are the different rules for creating interfaces? We have seen the different rules for abstract classes. Now, rules for creating interfaces. First rule, every method of interface is by default public and abstract. Okay, therefore it is 100% pure abstract class. We will see that through example. So here, in the abstraction itself, I'm creating a new package named interfaces. And inside the interfaces, we will create first example of interface. You can create the interface directly here. Okay. Same as the class, interface can be saved in a separate Java file, which is a public interface. Okay. Same as the class file, you can create a separate interface, or inside a class file also you can write an interface, but that will be not public interface. Okay. So here I am going to use a class itself to show you the use of interface example. In this, I am including the main method as well. Now we will write the interface. Interface is always written with the interface keyword. जैसे हम class keyword use करते हैं, you have to use interface keyword for writing an interface. Interface, you can write an interface outside of the class, inside of a class, okay, anywhere. Like nested classes, you can write interface inside a class as a member of the class also. After interface keyword, you have to write the name of an interface. So here, suppose I am using some name. We will give some name like demo. Okay, I am giving the name demo for this interface. Okay, interface demo. Now, in this interface, you can write methods. All the methods should be abstract methods. Okay, so suppose you are writing void display. I'm writing void display method. Okay, and using semicolon. So this method is by default public and abstract. That means the signature of this method is public abstract void display. Okay, this is the signature for this particular method. But in interface, whenever you are writing an interface, you don't have to write this. You don't have to make any method as abstract method externally. It is internally by default public and abstract. Okay, for the difference between abstract class, anytime whenever you are writing any method, abstract method, you have to declare that method as abstract externally. You have to make that method public externally. Okay, you have to make that method externally as change that visibility. That's why I need to do that everywhere. Okay, so you have to make this externally whenever you are writing any abstract method inside abstract class. But in interface, it is by default abstract method, and it is by default with the public accessibility, because we have to provide the implementation to this. That's why this method should be public. Okay, so that is the first rule whenever we are writing interface. So every method of interface is by default public and abstract, and that is why it is 100% pure abstract class. There is no concrete class, concrete methods inside the interfaces. That is why this is 100% pure abstract class, and that is why we say that interface is full abstraction. We can achieve fully abstraction. But this rule is till JDK 7 itself. We can use this rule until JDK 7 itself. When the JDK 8 onwards, new type of methods are allowed into the interface. Those methods are default method, static methods are allowed, and in JDK 9 onwards, private methods are also allowed in interface. That's why this statement is not valid for current JDK versions. Okay, this is valid till JDK 7. So you can use this statement till JDK 7 is only. So after JDK 8, two concrete methods are allowed. So these are concrete methods, default. This is not an accessibility. Okay, it is a specific keyword we are going to use for creating default methods. Then static methods are allowed into interface. private methods are allowed inside the interfaces. That's why these all are concrete methods. And that is why the interfaces are not pure abstract classes nowadays. Okay, so that's why it is not fully abstract, you can say. Now interfaces are not fully abstract. So we need to use interface keyword to define interface, which we have just done. Okay, this is the syntax. Syntaxes, interface, interface keyword. Then we are giving some name to this interface, that is interface name. Declare constant fields, declare methods that are public abstract by default. And the optionals are concrete methods, that is default, static, private methods inside an interface. Okay, these are concrete methods. Default method is concrete, static method is concrete, private method is also concrete method. So this, we are writing the concrete methods inside interfaces. That is why it is not fully abstract nowadays. But before JDK 8, we were using the same statement that it is a fully abstract. We can achieve the fully abstraction through interfaces. Okay, so this is example. Here we have created one interface named demo. This method is by default public and abstract. You don't have to make that method externally as abstract or public. It is by default public and abstract. Okay. Now, when we want to provide the implementation to these methods of an interface, you have to use implements keyword, because we are going to implement all these functionalities, right? We are going to implement all these functionalities. We are going to provide the implementation to all these methods. That's why we are going to use implements keyword to implement an interface into a class. Okay, we always implement it into a class. So class, that is the reason statement where we say that interface is a blueprint of class, because we are listing down all the functionalities and we are simply implementing all those functionalities in a class. Okay, so that is the reason class interface is a blueprint of class. So here, if we want to provide the implementation to this demo interface, we have to create a class. I'm giving some name, demo IMPL, that is implementation. After that, you have to use implements keyword. Okay, after implements keyword, you have to mention the name of an interface which you want to give an implementation. Here, the name of the is demo. So here you can see there are two fixes available. You have to add an unimplemented methods. So the unimplemented method is display method. I will write some implementation to this. System.out.println display method of demo implementation. Then the same rule also applies to this as abstract classes. If you don't want to provide the implementation of any of the abstract method, then you have to make that class as an abstract class. Same thing, you can use the same rule here for the interfaces also. So here I am going to use one more class. Suppose that class is demo IMPL 1, right? And I'm implementing this implements demo, but I don't want to provide the implementation to this display method here into this class. Okay, so I will make this demo IMPL1 as an abstract class. So here, this method will be as it is, public abstract void display will be as a member of this class. Okay. And you can create any other methods if you want into this abstract class. So this is by default available here. That's why this class is abstract class. So if you are making this class as an abstract class, who will provide the implementation to this method? Again, the child class of this demo IMPL1 will provide the implementation to this display method. Okay. So this is, we are using implements keyword for implementing interface. And we use extends keyword for extending a class. Okay. The same syntax is here: class, class name, implements, interface name, implementation to all public abstract methods of an interface. Okay. Only abstract methods. If you are writing this concrete methods, we are not providing the implementation to the concrete methods. But if you want to override these methods, you can always override it. Okay. That we will see later when we learn all the things related to interface post. Okay. So interface variables, you can define the variables also inside an interface. Interface variables are by default public static final constants, which are never going to change. You have to provide the value to it. Okay. Okay. So the interfaces variables are always public static final interfaces. You can define the interface variables. Suppose the name of the variable I am defining here is string institute name. Okay. You cannot do this. Okay. You have to provide the value to this variable immediately, because this is a final field. By default, this, 1 second. So by default, the signature of this field or how it will get declared in interfaces is like this. This is final static. We have seen how to declare the final static variables, right? Final static string institute is equals to whatever the value you are going to define, that will go here. Okay. So same, this is, we are writing in a normal way. In a class, if you want to define any final static variable, constant field, then you can use this syntax, right? But in interface, this is by default. Okay. So this, whenever you are declaring any variable inside an interface, that is by default final and static. Okay, it is by default final and static. That is why you have to mention some value to it. You cannot keep it blank. You cannot only declare it. You have to define that variable immediately. So I'm using here Stuintern. Okay. You can access this same as the previous static members using the interface name. Okay, if you want to access it, you can access it. So I'm accessing that variable here into this particular display method, suppose. Value of institute is equals to, we can access it using interface name. So interface name is demo dot institute. Okay, because it is a static variable, and you know that when we are accessing the static members using the class name, you don't have to create the object of it, right? So we can access it directly with the interface name. This is the rule. So whenever implementing methods of an interface, compulsory declare that method as public. You can declare that method as public itself whenever we are implementing. It is whenever you are overriding that method of an interface, implementing a method, it is, we have to make it as public itself. Why? Because this syntax of or the signature of this interfaces methods are by default public and abstract. By default, the public accessibility is given. That's why you have to compulsory use the public accessibility itself. In abstract classes, you can change it. You can increase it visibility. You can increase the visibility. But in interfaces, it is by default public. All the methods should be public with the public accessibility itself. Okay. Clear till here? Anyone has any doubt? यहाँ तक किसी को डाउट है, कुछ समझ में नहीं आया है, ऐसा कुछ है?
So can we declare the constructors inside?
In interfaces, it is not similar as classes. Okay,
Classes,
where
correct.
we cannot declare the constructors.
Yeah, but constants, fields, variables with initialization, as well as abstract methods, right? These we can declare.
The final static variables, which are constants, and
yes,
abstract methods, and few concrete methods after JDK 8 version.
Okay.
Okay, so you can see I am trying to define the interfaces constructor. It is not taking because interfaces never have any constructor.
Okay.
There's one more difference between abstract class and interfaces. That is, we cannot define the constructor in interface, but we can define the constructors in abstract classes.
Correct. Because that is a class and this is just a collection of pure abstract functions.
Yes, it is, you can say it is a blueprint of class.
Okay. So is there anything like in JDK, JDK 9 or something else? Can I go for the function definition? Suppose if I'm writing void display, inside that, can I write some content? Or is it like a pure abstract functions?
No, this is a pure abstract function. Okay, sorry, not function. We never use functions in Java. Okay, always use a method keyword.
Okay.
So in Java, we always use method. Functions are in C, C++, and other C#, etc. But we never use functions word for the methods in Java. Always use method word. Okay, so whenever you are, if you want to provide the implementation to this method, you cannot do that here itself. That will not be the concrete method. The concrete methods are different with some specific keywords. Those are, I have mentioned here, those are default, static, and private methods. Okay, so default methods and static methods are allowed after JDK 8 version, and private methods are introduced in JDK 9 version. So these are concrete methods. You can, if you want to provide the implementation, you have to make those methods, or you have to use any of these 3 keywords to create that method and provide the implementation. Normal method will never have any implementation inside the interface.
Okay. So if I'm writing some static methods along with the along with some content, so that is getting fixed in the interface. So wherever I implement this interface, that particular function can be used.
Yes. That is a static member.
Static method.
So same as the static member, you can access it by using the name of an interface.
Okay.
Okay. So as we have seen, we can overload the static methods. You can overload the static methods. All the you can say all the inheritance concepts. That means whatever we have seen, the different types of inheritances, all those apply to the interfaces as well. Okay, same as the class, all those gets applied to the interfaces as well. That means it has the single inheritance, it has the different inheritances, hierarchical inheritance, and we can achieve multiple inheritance also through the interfaces. Okay, how that we will see later. But all the types of inheritances, all the concepts of inheritances will be applied to this interfaces as well. As we are overriding this method, that means again the polymorphism concepts are also there, right? So you can overload any method, you can override a method. You have to override a method because we are providing the implementation. You compulsory have to override any abstract method. So overriding concept, that means runtime polymorphism concept is also there. Compile time polymorphism also you can use. Suppose that this is void display method. You can change the display method and add some implementation to it also. Oh, sorry, not implementation. You can provide,
different type of parameters.
yes, different type of parameter also. So this is an overloading concept, right? So you can overload method. You can overload, that means static polymorphism, or you can say compile time polymorphism is also there, and runtime polymorphism is also there. So this is an, again, this will become the public abstract method. So you have to provide the implementation to that as well. Okay. So suppose I am giving system.out.println, I am simply using s string, which I want to display on the screen. I'm not going to add anything else. Clear? So polymorphism concepts, inheritance concepts, all will be there. You can use all those concepts in interfaces as well. Why I'm saying this, because most of the time students get confused and they always think that this is only for the classes and we cannot use this for interfaces. No, it is similar to the interfaces, similar to the classes, right? Only the difference is we can only write final static members and only abstract methods inside an interface. That is why all the inheritances concepts, polymorphism concepts, we can use inside the interfaces also. Okay. Encapsulation is there because we are encapsulating the members, the different variables and methods inside a single entity. That's why the encapsulation concept is there. And abstraction, we can achieve the abstraction through this interfaces, right? So all those four pillars are, we are using all the functionalities inside an interface also. Same as the classes, we can use those inside interfaces also. Okay. Till here, anyone has any other doubts? Clear? All these rules. We have simply defined one interface, how to implement the methods of an interface that we have seen. Okay. We have not yet seen how to call those methods, how to initialize the interfaces. We have not yet seen those things. Okay. So whenever you want to implement interface, you have to use implements keyword. Whenever you want to extend any class, you have to use extends keyword. Okay, remember these things. Next rules. So whenever implementing an interface, provide implementation for all methods, or if unable to provide implementation to do at least one method, then that is the partial implementation using abstract, which we have done here using abstract class. This class I have created as abstract class. Why? Because I don't want to provide any implementation to this. Okay, you can skip only one, you can skip all the abstract implementations also. If you want to provide implementation to this method, you can provide it, and you can skip only for one abstract method as well. Okay, it is up to you. But if you are not providing any implementation or at least one method's abstract methods implementation in this class, you have to make that class as abstract class. Okay, same as the abstract class rule. Then child class is responsible to provide remaining implementation. The example is interface interrupt. There are two methods which are abstract. Okay, so this is a service provider class, which is implementing this interface one and providing the M1 methods implementation. So only M1 methods implementation, and it is not providing M2 methods implementation. That's why this class is abstract class. So we have created a separate child class where it is extending this service provider class and providing the remaining implementation of M2 method. Okay. So this, which is abstract inside this service provider class as it is. Okay. So that's why this is child class is responsible to provide the remaining implementation, whatever the remaining implementation. Suppose there are hundreds of methods inside an interface and you are providing 50 here and 15 child classes. That is up to you. Okay. So whatever the remaining methods are, the child class is responsible to provide the implementation. Java has multiple APIs. APIs means application programming interfaces, right? So I stands for interface. So all there are multiple interfaces provided here into the Java, which we known as APIs. Okay. For example, JDBC API, Servlet API, which provide you some methods to implement and develop your own application. So you can see those JDBC API. That means there is java.sql. So there are few classes and few interfaces provided in the JDBC API. I will only give as an example. This is an interface driver class, which is an interface. Okay, so if you open it, this is an interface which is under the JDBC API. Okay, this is interface under the JDBC API. The java.sql package is nothing but we say it as a JDBC API, and it has multiple methods, only listed methods. Okay, all these are public abstract methods. So public abstract methods, which if you want to create your own JDBC application, you have to use this driver interface and provide the implementation to all these methods, and you can use it. Okay. So basically, there are multiple APIs inside the Java. Java provides multiple APIs for developing our own applications. Those are interfaces. I stands for interfaces. API has I, that is interfaces. That is nothing but they are providing only the methods, which is you can use to develop. You develop these methods and you can develop your own application. Okay, you can implement these methods and you can develop your own application. Okay, so this is JDBC API, Servlet API, Swing, then Java, FX. There are multiple APIs in Java. These are few examples which we are going to use. Okay. Next point is properties of an interface. Interface is used to achieve fully abstraction. Java interface also represent easy relationship. We have seen easy relationship in inheritance. It is also an easy relationship. A class implements the interface and overrides the method of interfaces. That is also we have seen through example. A class can extend a class and also can implement an interface. That we will see through this example. We can create one child class of this class demo IMPL. One child this is the name of the child class, which is extending demo IMPL 1. Okay, and it can also implement demo interface. Okay, so a class can extend a single class because multiple inheritance is not possible through classes, right? Class can extend a single class at a time. We can extend only one class at a time. That's why here this class is extending this parent class, and it can also implement another interface. Here I am using the same interface. You can use another interface as well. Okay. So this is the property. A class can extend a class and also can implement interface. Same thing here. A class service provider extends service provider and implements interface. Okay. So this is the example. An interface cannot implement an interface because the interface is fully abstract. Suppose you are trying to create one interface. Interface X is implements demo interface. No, this is wrong. One interface never implements another interface. Okay. This is not possible. This is property where one interface cannot implement another interface. Same interface show implements interrupt, wrong definition. Next property is interface is used to achieve indirectly multiple inheritances in Java because an interface can extend more than one interfaces, or you can say two or more interfaces, but class cannot extend multiple classes, right? So that's why we can achieve the multiple inheritance through interface. Interface show extends first interface, second interface, multiple interfaces. But a class sub-service provider extends service provider, it is not possible, right? This is a wrong definition. This is a correct definition. That's why in a property of interface, we can achieve multiple inheritance indirectly by extending more than one interfaces. So suppose here I am creating interface show which extends demo. Okay. This is a single level inheritance. Again, suppose I am creating one more interface. Interface sing which extends show and show comma demo. So multiple interfaces you can extend here. Extends means we are using inheritance concept, right? So this is inheritance concept. So we can extend multiple interfaces in a single interface, but class में वो possible नहीं होता है. An interface cannot extend a class. This interface show extends a service provider. This is a wrong definition. Interface only extends interface and class extends only class. Okay. So suppose this is the statement class X, sorry, interface dance extends demo IMPL. This is not possible. Okay, this is wrong. So here super type should be inheritance, interface itself. We cannot use classes. This is the next property. A class implements interface, but one interface can extend another interface. Okay. Class implements an interface, but one interface can extend another interface. A class must either implement all methods of its interface to be implementing, or it should be declared abstract. This is, we have already seen part. Okay. So this is a class implements interface. One interface can extend another interface. So suppose this is show method. It has one method that is void show itself. Okay. It has one method void show, and this is void sing method inside sing interface. Okay. Now, if I want creating one class implementation, which implements this particular sing interface, okay, where we are basically extending another interfaces. So this sing interface has show method as well as demos display methods. Okay, so you have to provide all the implementation to the all the methods. So if you go here and add unimplemented methods, then you can see you have to provide show methods implementation, display method implementation, overloaded display method, and the sing method as well, because this sing interface is an extended interface. Okay, it has only sing method, but from parent interfaces, you always inherit all the members, right? So we are inheriting the members of show interface, that is show method. From demo, we are inheriting these two display methods and a static member as well. Okay, that is not overridden. It is by default available. Okay, so whenever you are you have inherited interface and you are providing implementation to that particular interface, you have to provide implementation to all the methods. That is a class implements interface, but one interface can extend another interface, then you have to provide implementation to all the inherited methods as well. Next is extended interface that we have already seen in example. Interfaces can be extended by another interface. That is nothing but the concept is inheritance in interfaces. The class implementing child interface must implement all the methods of both parent and child, which we have seen through that example itself. Okay, or it should be declared as abstract class if you don't want to provide implementation to any of the abstract method. Okay, this is the syntax which we have seen just now through this example. Okay, how to extend, create an extended interfaces, how to provide the implementation to it, that is also we have seen. Till here, anyone has any doubt? Clear?
So if the one interface extends one more interface, we are using the extends word, right? Just like how we are having in class.
Yes.
But once the class is implementing the interface, we are using implements.
Yes.
Okay.
So extends keyword is always used for inheritance concept, and implements keyword is always used for abstraction interfaces concept. Clear?
Yes, yes.
Till here, anyone has any more doubts? Shall we go ahead? Same as the nested classes, we can create nested interfaces as well. That means we can define an interface inside another interface or another class. Okay, that is known as nested interfaces. So suppose there is this interface show. Inside that we are defining interface view, and there are two different interfaces, outer interface and inner interface. You can define it as an part of or member of the outer interface. It will get protected from outside world. Same as the nested classes, we are protecting the internal interface from outside world. Okay, so it will become member of outer interface or class. It can be declared private, default, protected, and public depending on your requirement. But it will be accessed via outer interface name itself, same as the class name. So we will define here one nested interface and creating one another class, or we will create interface itself. New interface, nested interface. The public interface, nested interface is created. Okay. Inside that, I am creating another interface. Interface, suppose show. Inside this interface show, the name related rules for the class and interface is same. Okay. If you want to give a name to the class and interface, it should start with a capital letter. And you can use special characters like underscore and dollar itself. We have seen the rules already. Same will apply to the interface name. So here I am creating show, and it has one method, that is void show. Now this is the inner interface, and this is an outer interface. If this outer interface has one method, suppose the method is sing method, or we will create one method, void display itself. Okay. So this is the inner interface, and this is an outer interface method. Same we can create inside a class as well. So you can define a class. Inside a class, you can define interface and the body of the class. Now the difference between class and interface. Implementation. Class can provide both variables and methods. Interface can only define method signatures. Variables are not variables. Those are not variables. Those are fields. Okay. Those are class, जैसे कि class members हम class fields define करते हैं, class variables define करते हैं. In that way, in interface, we can define fields. Okay. Object creation, we can create the object in a class using the new keyword directly. We can instantiate it using new keyword. But in interface, we cannot create object directly. We cannot instantiate it directly because you know the abstract class concept, right? We cannot create the object of abstract class. Similarly, we cannot instantiate interfaces directly. A class has access modifiers, variables and methods for variables and methods, but interface has by default public access modifier for all the methods and variables. We can extend a class, it can inherit other classes. We can extend multiple interfaces, that is, interface supports multiple inheritances. A class can contain constructors, an interface does not have a constructor. In a class, variable can be static, final, or neither. All variables are static and final in interface. A class cannot contain abstract methods. Abstract methods means if you want to define any abstract method, you have to make that class as abstract class. That's why this statement is here. Okay, don't get confused. In abstract class, you can define the abstract methods, but in a normal class, you cannot define abstract method. And in interface, it contains all the abstract methods. Clear? The difference between class and interface? Any doubts? Okay, so today we will end our session for today here. Okay, and we will continue with the how to create or how to instantiate, how to call the methods of the interfaces by creating objects in tomorrow's session, as yesterday's session was rescheduled tomorrow. So we will continue tomorrow with the next points and the object creation in interfaces. Thank you, everyone. We will end our session today here. I have already uploaded the assignments. Please go through the assignments and complete it.